Okay, welcome. This is 8.6. We're going to solve quadratic inequalities by graphing. This first one, they have already done the graph for us, and we're just going to see how that's super useful. So, pause, write down these rules, and then we're going to use them. Okay, number 1, complete the following using the above graph. The solution to the inequality x squared plus 2x minus 8 is greater than 0 is. So this means when is this graph greater than 0 or meaning above the x-axis? So if I look at my graph, well, it's above the x-axis here and here. So I can just look and write here, x is, this is 2, so everything that's greater than 2 in my domain, if I squish that down, all these. So if x is greater than 2, or if I squish these down, x is less than -4. And notice I'm using less and, greater and less, not with the equal signs, because that's what it said here. B part, the solution to the inequality x squared plus 2x minus 8 is less than 0. So where is my graph below the x-axis, which is here? Anytime I pick an x that is greater than the -4 and less than 2, I will have points on the graph which will be below the x-axis. So -4 less than x less than 2. They're going to show that here on a number line. So notice that is sort of what we scribbled in here for A, and B, yeah, kind of what we scribbled in there. They'll use the open circle because it is not including the -4 or the 2 in either of those cases. Okay, number 2. Give this a try, pause, and then see how we do. Okay, so it wants us to graph this, and then we want to find out when is it greater than or equal to 0. So I'm going to factor. So how about 4 and 3, x and x, I need a minus and a plus. Nope. How about 6 and 2? Positive 6 minus 2, yes. So 6 minus x and 2 plus x is, and they want greater than or equal to 0. So my x-intercept is going to be 6 and -2. So 6 and -2, and we are not going to do a good job of these because it just takes too long. And we don't care. We are just using this parabola to find what we want. Okay, so solving this, we know greater than the x-axis, so greater than or equal to 0 are those, which means x is less than or equal to -2 and x is greater than, equal, greater than or equal to 6. So on a number line, -2 and 6 and shaded, so a solid dot, and above and below. Then the solution to the less than or equal to here. So -2 less than or equal to x less than or equal to 6. Great. Not number anything. Next, this solving algebraically and just not doing the number line, they do this nice case analysis. You may use case analysis in your later math life, But I would just remember this because you can do this instead, and it's just so much easier. So big star, and this is a keep forever. So case analysis is nice, but the Scrappy graph takes care of everything instead of all of this and all of the next page. So go to page 538, and we are all ready to do example 3. So when we solve these, you have to do a Scrappy graph to solve, otherwise you have to use case analysis. I don't like using case analysis because it's too long, so let's solve. Let's factor, so 5 and 1, 3x and x. I need a plus and a minus. Nope. How about if I switch these? 1 and 5. I get plus 14, so if I switch my signs, yes, now I've got negative 14. So 1 minus 3x and 5 plus x is supposed to be greater than or equal to 0. When is this equation greater than or equal to 0? And from there, you cannot tell whether you should put the greater than, less than, which one goes with the x-intercepts. So let's just do my x-intercepts are going to be opposite sign, number divided by the number with the x. So positive 1/3 and negative 5. Then I'm going to make just a Scrappy graph so that I can tell on this. And 1/3, negative 5. And my graph, my parabola is upside down. That's important. And now I want when is the equation or the line greater than 0? So greater than the x-axis, there. So x is going to be negative 5 less than or equal to x less than or equal to 1/3. Nice. On your questions, so you're going to do 3 and 5. These are ones that you're just going to factor and draw a Scrappy graph. Do not do case analysis. You are factoring, doing a Scrappy graph so that you can tell this. That's where that comes from. You cannot tell from here what your answer is going to be there. And then number 6, it's hard and you'll like it. You need to remember your discriminant rules, and those are somewhere about page 341. Okay, enjoy.